Welcome to a lesson with Dr. Powell. Okay, let's finish out this example. This is what we obtained in the last video. So this right here, if we regroup the addition, because thinking of this is like we're adding a bunch of things which are something minus something else. For example, this minus this, that minus that, whatever. Well, what if we regroup it, like put all these first guys together and all these last guys together, and then factor out a negative and just add them. So you can verify that this line is the same as this line. Using the same logic, the same idea, we could rewrite this as this. Further, notice that the only thing that changes from term to term is this k, and it's multiplied by something which is the same in every single term, like here. So this is the same, meaning we can just factor it out. I mean, think of this summation symbol, sigma notation, as just a big set of parentheses. This can just factor out. Same thing with this factors out, since this is the same in each term, factors out right here, so we end up getting this. Now we're going to use some facts to help us, and you're welcome to use these. Right here, the sum of k from 1 to n is simply just this. We have a formula for this. Now, one way of thinking about this is just the same as adding 1 plus 2 plus 3 all the way up to n. Now, the average of all these numbers is because of symmetry, it's the exact same as the average of the first one guy and the last guy. There's n plus 1 over 2. That's the average of all those numbers. Well, what do you do with, well, what is an average? An average is equal to the sum of everything divided by how many there are. So if you know the average, you simply need to multiply by how many there are to get the sum. So that's exactly what we're doing. N times the average here. So n times quantity n plus 1 over 2, that equals this sum. This guy right here is there's a little bit more to it, and actually figuring out. So I won't go through that process of why this formula is true. We'll just use it. But really, what we're doing is we're adding up all the squares. 2 squared, 3 squared is 9, 4 squared is 16, all the way up to n squared. It's kind of what we're doing. But this has a nice formulaic structure right here. So we can basically just insert these right in here. This one for this son, this guy, this one for that guy, and then take a limit. Now in our limit, we're going to actually use the fact that we have a polynomial in n over a polynomial in n here. Let's just take the limit of this right here. Let's not add fractions. That's too much work. So if we're taking a limit of a polynomial over a polynomial, really all we need to do is look at the leading terms. So that's what I've done here. The leading term, how do you get it? You just take the leading term of each factor, multiply them together. That's what you get on the top. On the bottom, that's what you get right there. And similarly over here. So then taking a limit is more simple. We can just take the limit of this, which is 8/3, and the limit of this is -4, subtract them, and we get the result -4/3, which you can actually check the integration. You will get -4/3 as well. Thanks for watching.